tell our technicians, and we've obviously learned through failure on projects. Our project managers are laughing over here. So we've learned on these projects that, hey, we probably shouldn't scan right after it rains and we have a ½ an inch of water, because with any laser data, what happens? Anybody know what happens when a laser hits water? Anybody? You don't get anything. There's no return. There's no reflection. So it might refract a different direction, but you don't get anything back. So we create this list of things that we want to avoid. Watch the weather. What's the vibration like during that day? Is there high-lows driving by? Is there going to be an earthquake that day? All these factors, all these things that happen, we should probably plan for them and know that we should tell our technicians, like, hey, this is what you need to know. Plan for that. Otherwise, we're going to greatly reduce the accuracy of our data. That's pretty important. So looking at a data set, how many scans, I calculate the time on site by how many scans you have to take. I know if I'm taking a colored scan with a Faro, it's at a 5th res, it's 6.5 minutes. I know that scanner's got to sit there in 6.5 minutes. And if I only have 20 hours on site, you got to calculate how many scans you can complete in that time. Do I need 2 or 3 or 4 scanners? But then how much data do we have to capture? What's important on that site? This site was kind of an irregularity for us. We wanted to capture every single detail that there was. So we took scans every 15 feet throughout the facility. It looks really dense, and it was. So what we did is we used this as our baseline running down the aisleways. It filled in a ton. We came back and we dropped in some scans in random places that helped fill in the centers. Some complexities we had here is we knew that there was going to be traffic, so we came in at downtimes and made sure there wasn't high-lows running by, because the floor can flex a little bit as the scanner is sitting there. So we made this nice and tight and had this redundant data. So in case the high-low did drive by and we did see a deflection in the data, that wheel that you saw with Chad, those 3 different factors, that'll show you, if you've got an issue with their data, you have so much overlap, you'll actually see that issue, right? And then you can drop the data. You can drop that scan out and throw it away. And since you have extra redundant data, you can continue on without having to go back out and rescan. One of the benefits of Recap is that by default, it'll actually filter your data for you. So you can turn that off, obviously, but when you export out your RCS file, which is still one of those native formats, it'll filter that down to reduce that redundancy. Each scan, by default, we want to have a minimum of 30% overlap. That way we know we have 30% from scan to master scan, that we know we have good data that we can compare it against. So when we're scanning these really large facilities, say take a 1 million square foot facility, we like to break them in chunks because we want more than one person working on it, aligning. So this project here, we dropped into 4 different chunks. 4 different people can work on it on 4 different computers, or one person with 4 different computers can work on it, and you can merge these projects when you're done. So this guy is in the southwest corner, this guy is in the southeast corner. You could take those 2 projects, bring them together, and it'll actually evaluate all the data that's along those edges. So it's not one scan to one scan. You're aligning the 20 or 30 scans that are on one side and the 15 that are on the other, and it'll evaluate all that data that's in between and calculate it for you. And again, we've got a large facility, so we've got survey data that will tell us, too, if we've got a deviation at some point. So when we're all done, we get a nice, good-looking scan cloud. This is not rendered out. This is just the Navisworks, a screen capture. Great-looking data, and again, it's really dense. So we captured, the metal on the fan blades, not just the fans, but like that 1/4 inch, metal that's around it. So it's literally every detail in there, and you can, with all those extra pictures that we took or extra scans, we can use that to read the fine print on the data sheets that are on each of the machines. So yeah. So our customers might use that. Some of the big box customers, Ford, for example, they model in every garbage location. So the garbage locations are important to them because they plan their logistics where they can drop parts at. So if it's an open space, they'll drop parts. If there's a garbage can they might not do that. So they might actually model that in. They model all the walkways. They model shared space. So it's to get this in color at this detail is pretty important to them. So it's taking it like, what level do you take this to? If you can scan at an inexpensive rate like this, you can afford to really capture every single thing and then some. So out of the first use out of a scan cloud for retrofits, we're doing quite a few of these right now, retrofit scans. We go in and scan the facility while machinery is either still running or they're decommissioning a line. It seems like to some people it seems like wasted data. They're going to tear everything out. But what we do right up front is we use the real view session, the data review session that's published online. We use the pictures from that. We reference where they're at in the plant. And then we use the scan data as the model. So traditionally, an AE firm would come in and model the whole facility just to show what they're going to demo. That's like $300,000, $400,000 to come in and model that whole facility that they're going to tear out. So we came up with a way to take a screen capture, just to slice through the scan data. Again, this is less than a third, depending on the size of the plant, the cost, and take sections through the data and then just highlight what we're going to model, what we're going to remove, and we reference it with pictures. So we publish that online. Anybody can take a look at it, and it's it's nice, fast, efficient way to publish information they're going to remove. The next step is we usually start with this 2D drawing that the customer supplies, and we go out and scan a facility. Why do we build 3D data when we have a scan that's accurate? So that's a question for the customer, I think, more in the use of it. We really do push live in the scan cloud if you can. All of the scans that are usually provided by anybody that's out there scanning now, they have the ability to align it to the drawing. They align it to the same space, whether you do it from a survey or you build that into your export from Recap. So I can align this data to that drawing. It's in the same space. So I either don't model anything and just use the 3D data as measurement, dropping new things that are going into place. If I put a new machine in here, I can cut that data out that's going to be removed, pop a new machine in. So that reduces issues. I mean, when you model something, you reduce accuracy. I mean, there's no two ways about it. If there's a bent column, you don't model the bend in the column. That's the most important thing, is you don't have the time for that. So if we can, we live in the scan. If not, we can remodel this. It just takes a little bit of time. It all depends on the use. So if you're building a Revit model, you may want to embed metadata. So it's important to figure out what your customer needs. Recap 360, or R360 as we refer to it. This is the user interface for it. Just recap, or 360.recap.com. You sign up for it. It's you get free 5 gigs of space. Play around with it. You can upload your pictures and do the meshing here we've been talking about all day with the drones or UAVs, with your iPhone pictures. This is a great user interface, very, very usable, very easy to use, but it gives you the ability to view both your recap scans and your recap pictures that you take, the meshes here. So you can view the triangle meshes. You can share these with other people. It's on a secure server. As soon as you have a seat of software that gives you a little extra space, like if you purchase a Seat of Recap Pro, you get 100 gigs of space. There's a lot of projects you can post up there. Some of the images that come out of, this is just a couple of screen dumps of scan data. So we're publishing the real view sessions. So we can look in these bubble views, which is everywhere the scan is taken. We can take measurements, just a few clicks for measurements. You can also drop annotations. So if you want to collaborate with somebody else in your group or with somewhere within your company, you can put, this is a fire hydrant, this is a door, where does it lead to type of things. You can put hot links in there or link it back to the location on your server. But it gives you lots of options for viewing. You can do different elevations if you've got a multi-story building. But again, that's the whole site. You can really walk yourself through that site on the web. To go with that, we've got in development right now, just iPad version. It's an app. So all of this runs on an app. So we're usually worried about sitting on the web all the time. This actually runs on the web, or you can download it locally. So if you're, some of the uses for it, if you're doing demo in a plant or in any type of situation, if you have a scan, you can go in there, put some asset tags while you're offline, come back, sync it up, and all the data would be up here online. So it'd be a way to be able to communicate on-site, off-site with people maybe that aren't sitting locally.